So we're in section 10.2 now, and we're going to talk about sine and cosine ratios. So on Friday, we talked about right triangles, and we said that if we have a 90-degree angle and we know one other angle, that any other right triangle with a right angle and whatever the other angle is are going to be similar, no matter how big or how small they are. So we can make a ratio out of the opposite and the adjacent side, and that ratio is going to be the same for any size triangle. So the ratio tells us something, has something to do with the angle. Well, we only talked about the opposite and the adjacent side on Friday. So today we're going to use some ratios that have to do with the hypotenuse of our triangle. But it's important to remember that trigonometry all has to do with similar triangles. The reason it works is because if we have a 90-degree angle and one other angle that we know, that any right triangle with that angle is going to be similar. And that's what lets us make our ratios. So let's draw our triangle again, just like we did on Friday. We'll call that angle A. And we said we could also call it theta. And our 90-degree angle is here. And we're going to label all the sides this time. So this side is the adjacent side. This side is the opposite from our angle. And the longest side, the side across from the 90-degree angle, is always the hypotenuse. So we're going to talk about ratios that have to do with the sides and the hypotenuse. Our tangent had to do with the opposite and the adjacent. Our sines and cosines have to do with the hypotenuse. So we're going to say that the sine of angle A or we write the sine of theta equals, and that is the opposite over the hypotenuse. So we take the opposite side divided by the hypotenuse and we get the sine of our angle. The cosine of angle A, we also write cosine theta is the adjacent over the hypotenuse. So these are our other two main ratios in trigonometry. The sine, the cosine, and the tangent are our three main ratios. Now the way that we remember these, we have a little saying that we use to remember these. You may have heard it before, SOHCAHTOA.
No, we didn't learn it, remember?
But you may have heard it before. SOHCAHTOA tells us that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So this is how we remember our three main trig ratios, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Now for the quiz, you're going to need to remember this. You're going to need to know which ratio is sine, cosine, and tangent. And this is an easy way to do it. Questions on what sine and cosine of an angle are? So when we're working with sine and cosine, it's just like we did with tangent ratios. If we know the sides of the triangles, all we have to do is write our ratios to find the sine or the cosine. So let's look at an example where we know the sides of a triangle and we'll calculate our sines and cosines. So here is our triangle. We'll say this is our angle theta, and we'll make this a 3, 4, 5 triangle. And we want to find the sine, the cosine, and the tangent of theta. We're going to calculate sine, cosine, and tangent of theta. So we have the sides of our triangle. We just need to write them in the right ratios for our sine, cosine, and tangent. So let's start out by labeling our triangle. Is 4 the opposite side, the adjacent side, or the hypotenuse? 4 is the adjacent. 5 opposite or hypotenuse? That's the hypotenuse. So that leaves the opposite side here. So if I know the sides, all I have to do is write my ratios to find the sine, the cosine, and the tangent. Sine of theta, opposite over hypotenuse, is 3 over 5, or 0.6. Cosine of theta, adjacent over hypotenuse, 4 over 5, or 0.8. And the tangent of theta, opposite over adjacent, is 3 over 4, or 0.75. So if we know the sides of our triangles, this is all we have to do is write our ratios based on what SOHCAHTOA tells us is sine, cosine, and tangent. Now what if we were missing one of the sides of our right triangle? This is a right triangle. So what always works on right triangles? Pythagorean theorem, a squared plus b squared equals c squared. So if we know 2 of the sides, we can figure out the third side. We can always figure out the third side with the Pythagorean theorem. So if we need to figure out one of these ratios and we're missing one of the sides, we can always figure out the third side if we have 2 of them. Questions on this example? Now with our calculator, just like we did with tangent ratios, if we know the angle, we use the sine button or the cosine button to find the ratio. So just like we did with tangent, if we know the angle, if they ask us for the sine or the cosine of some angle, we can just use the sine or cosine button in our calculator. If we need to find the angle, so we know that we have the ratio and we want to find the angle, we use the inverse sine or the inverse cosine. So if we want to find the angle, we use the inverse button. And the button that we choose depends on whether we know which parts of the triangle that we know. So we'll look at a couple of examples. If we know the angle, we just use a sine or cosine. Just like we did in the opener, we had an angle in our triangle, so we used the tangent. We had to find the tangent of 52 degrees. We used the tangent button in our calculator to find the tangent of 52 degrees. So let's look at an example using inverse tangent, or I'm sorry, inverse sine and inverse cosine. So we're going to use our 3, 4, 5 triangle again, just because we figured out our ratios already. So here's our 90-degree angle. Here's our angle theta, and this is our 3, 4, 5 triangle. We already decided this is the adjacent, this is the opposite, and this is the hypotenuse. And we calculated our ratios already. We know that the sine of the angle from our first example was 0.6. If we know the sine of the angle, to find the angle, theta is the inverse sine of 0.6. And to find that in our calculator, I'm just going to go to my calculator. I'm going to do second to get to my inverse sine of 0.6. And I get 36.87 degrees. So I wanted to find the angle, so I used the inverse sine. If we have the cosine of the angle, so we know that we've calculated already that the cosine of the angle was 0.8. We did that before in our example. So we could say that theta, our angle, is the inverse cosine of 0.8. Now, should this turn out different, you think? Is this angle different depending on whether we're using sine or cosine? It's the same angle, right? So our answer should come out the same. So let's do the inverse cosine of 0.8. And we get 36.87 degrees. And we could also calculate our angle with the tangent ratio. We figured out before that the tangent of our angle was 0.75. So our angle is the inverse tangent of 0.75. We're still talking about the same angle, so we hope this comes out the same. So let's do a second. We're doing inverse tangent of 0.75. And we get 36.87 degrees again. So questions about using our calculator? Same process that we used on Friday. All right, let's talk about solving problems. Let me just write this real quick. Okay. All right, solving problems. I'm going to list our steps. Our steps are almost exactly the same as the steps that we talked about for using the tangent ratio. We just have one thing to add. So our steps. If you follow these steps, you should be able to set your problem up right every time. So we want to label. We want to label the triangle. By label, we want to figure out which side is opposite which side is adjacent, which side is hypotenuse. So we get our sides labeled right. Our second step is decide which ratio to use. Depending on which sides of the triangle we have, will tell us whether we're going to use, and what we mean by this is we pick sine, cosine, or tangent. The sides that we have tell us which ratio to use. Do we have the opposite and the hypotenuse? Do we have the opposite and adjacent? Which ones do we have? That'll let us know which ratio we need to use. So this is really the only different step. Our third step is write an equation. And our equation is going to look like the sine of the angle equals the opposite over hypotenuse, the cosine of the angle equals the adjacent over hypotenuse, or the one we used before, the tangent of the angle equals opposite over adjacent. So depending on which sides we have, tells us which ratio to use, and that tells us which equation that we need to write. Our fourth step, just like before, we're going to solve for what we need. And finally, at the end, we're going to use a calculator. So it's the same process that we used on Friday with the tangent ratio. Questions on our steps? All right, let's take a look at some examples. So our first example, we want to put a 12-foot support wire on a tree. We want it, and it makes a 30-degree angle with the ground. What we need to know is how high up the tree we need to attach it, and how far from the base. So let's draw a picture for this one. If the problem doesn't give you a picture, it helps to draw a picture. So here's our tree. And we're putting a 12-foot wire. So here's the wire. It's going down to the ground here. And here's the other part of our triangle. So this is a 90-degree angle, and we want the wire to make a 30-degree angle from the ground. And the wire is 12 feet long. So we want to know how high. So that's going to be this side. And we want to know how far from the base. So let's call this side D. We want to figure out H and D. Let's say our house is over here. So we want to make sure we have enough room to run the wire out this way. So there's our house. Want to make sure we have enough room here. So let's start off following our steps. Let's label our triangle. Is D the opposite, the adjacent, or the hypotenuse? That's the adjacent side. 12, opposite or hypotenuse? That's the hypotenuse. H is going to be our opposite side. So we have two different problems to do here. We're going to do one for h and one for d. So let's find the height first. Let's figure out how high up the tree we're going to attach this wire. We want to attach a wire here because it's really windy. So there's a cloud. So it's really windy. We don't want the tree to blow over. So let's look at the height first. How far up? So we have the hypotenuse, and we're trying to find the opposite side. Which trig ratio tells us about the opposite and the hypotenuse? Sine. So I'm going to write my ratio that I'm going to use as a sine ratio. And I'm going to write my equation. The sine of the angle. Here's my angle. Sine of 30 degrees equals the opposite, h, over the hypotenuse, 12. Now I solve for the part that I need. To get rid of that 12, I want to get h by itself. Multiply both sides by 12. Those go away. So I get h equals 12 sine 30 degrees. And my last step is to plug into my calculator. So let me clear this, clear this. So I'm going to do 12 times the sine of 30. And I get 6. So we're going up 6 feet. So this equals 6 feet. So we're going to attach our wire 6 feet up the tree. So that wouldn't make a very good zip line. It wouldn't be very fun, only 6 feet up. So now let's find our D. So we could use, we know that we have the opposite side and the hypotenuse. So we could use tangent, has the opposite and the adjacent. But since we're working with sines and cosines today, let's use cosine. Cosine is adjacent over hypotenuse. So I'm going to write that equation. Cosine of 30 equals the adjacent, d over 12. So solve for what we need there. Multiply by 12. Those cancel. I'm multiplying that side by 12 also. So I get that d equals 12 cosine 30. Last step, plug into the calculator. 12 times the cosine of 30. And we get 10.39. So d equals 10.39 feet. So I'd have to go out 10.39 feet from the base and 6 feet up to make a 30-degree angle with this 12-foot guy wire. Questions on that example? Label our sides. Depending on which sides we have, we pick our ratio, write our equation, and solve our equation. All right, let's look at another example. This is our triangle this time. And we have, this is x. Here's our 90-degree angle. This is 52 degrees. And this is 8. And we want to find x. So this one will be a little easier to set up. All right, so let's follow our steps. Label our triangle. Is x opposite, adjacent, or hypotenuse? That's our hypotenuse. 8 opposite or adjacent? Adjacent. It's next to our angle. Opposite means across, adjacent means next to. So what trig ratio tells us about the opposite and the adjacent? Tangent tells us, which tangent tells us about opposite and adjacent? Which one tells us about opposite and hypotenuse? Sine tells us about opposite and hypotenuse. Which one tells us about, in this problem we have adjacent and hypotenuse. Which tells us about adjacent and hypotenuse? Cosine. So we're going to write our equation with cosine. Cosine of 52 degrees equals the adjacent over hypotenuse, 8 over x. Now we need to solve for the part that we need. How do we get x out of the denominator here? Multiply by x. Multiply both sides by x. Those cancel. And I get, I'm going to turn it around, 8 equals x cosine 52 degrees. And cosine 52 degrees is just a number, so how do I get x by itself now? Divide both sides by cosine 52. Those go away. And finally I get x equals 8 divided by cosine 52 degrees. My last step, plug it into my calculator. So I'm going to do, let me clear this out. So 8 divided by the cosine of 52 degrees, 12.99. So x equals 12.99. Questions on that example? So we just labeled our triangle, picked our ratio. Finally, after we went through all three of them, we picked cosine. And wrote our equation, solved for what we needed. All right, let's look at one more example and we'll be done. So here's our triangle for this example. This is theta, this is 7, and this is 15. We want to find theta this time. So we're trying to find an angle. When we're looking for the angle, what do we have to do? What do we have to use? When we're looking for an angle, we have to use inverse. When we're looking for the angle, we have to use the inverse. So this time we're looking for theta, we're looking for the angle, we have to use the inverse. So let's label our triangle, and then we know we're going to use an inverse. So 7, opposite, adjacent, or hypotenuse? 7 is opposite, all the way across the triangle. 15 is the hypotenuse. I didn't label our 90-degree angle, but there it is. All right, so what trig ratio tells us about the opposite and the hypotenuse? Sine. So I'm going to write sine theta is 7 over 15, opposite over hypotenuse. I am looking for the angle, so I have to use the inverse. Theta equals the inverse sine of 7 over 15. Now I plug that in my calculator. Let me clear this out. So I'm going to do the inverse sine of 7 divided by 15. And I get 27.82. So theta is about 27.82 degrees. So when we're looking for an angle, we have to use inverse. Yeah.
What is theta?
Theta is just the name of that's just, in trigonometry, that's just what we normally name angles. It's a Greek letter. It's part of the Greek alphabet.
Just like saying angle x.
Just like saying angle x.
Oh, okay, so it's like, what is that
Yeah.
supposed to mean?
It's just a letter that we usually use to talk about angles. We could call it x, and it would be exactly the same. It is Greek, yeah.
Right?
All right, questions on that example? So remember, when we're trying to find an angle, we have to use one of the inverse sine, inverse cosine, or inverse tangent, depending on which sides you have. All right.